We are the Sun Devil Waste Consultants from the Engineers Without Borders chapter at Arizona State University, here to give our closure plan for the Back Hotel landfill, as well as the plan for a new landfill. Meet our team. My name is Sam. I will lay out our general goals for the closure plan. Then Tyler will describe our closure plan in further detail. Kathleen will describe our new landfill site plan, and Vinay will cover our cost estimates. And I just wanted to give a huge shout out to Dr. Kavazanjian, or Dr. K, without whom this project would not have been possible. Dr. K is the director of NSF Engineering Research Center for Biomediated and Bio-Inspired Geotechnics here at ASU. He's an awesome and experienced professor. During this project, he was super supportive and helpful, a reliable source of knowledge and experience, and always willing and wanting to give advice and guidance. So I just wanted to give a huge shout out and thank you to Dr. K. Now, onto our general goals for the current landfill closure. We wanted to securely close this landfill first and foremost, as it exists in a developing and growing part of the country, close to where people in need of clean living conditions live and near lots of surrounding water. This means that the landfill closure needs to be secure and safe from erosion, with precautions made for gas escape. On top of this, we decided to put a public park space that the local people, plants, and animals can all enjoy and benefit from, as to further our environmental impact. Also, for the people, we wanted to create jobs. Fortunately or unfortunately, many of the local people reuse and repurpose objects found either for personal use or for sale. They essentially rely on scavenging this landfill as a means of living. Closing this landfill could then create devastating frictional unemployment for some of these people. So on the far west side of the site, we placed a transfer and recycling station where people can deposit and trade waste or find a job as a waste transfer. That way, these scavengers can apply their skills in a safe and clean way. Our final goal was to create a sustainable and long-term landfill, relatively far away from development. Considering that the country is developing, it will likely continue to become more dense, especially in already populous areas. One of the issues with the current landfill is its location. Right now, it's in the middle of the country's dense area, located near the north shore of the Southern Peninsula. So we wanted to make sure that the new landfill would not be near these areas. Now I'll give it on over to Tyler so that he can talk about our closure plan.
We will now go over our plans for the closure of the current Back Hotel landfill. The post-closure of the Gambia landfill will include a transfer station and recycling area in the northwest corner that has access to existing roads, a park that contains a vegetative soil cover over the waste with walking trails and a water feature that also doubles as a drainage basin for the site in the low-lying area in the northeast. The plan will offer opportunities to employ local residents at the recycling center and as workers doing inspections, gas readings, and maintenance for the soil cover and water feature / drainage basin. Now, to accomplish the desired drainage of the site, we will need to be graded in a way that can be seen in this contour map of the landfill. The final fill contours in the figure include areas both above and below existing grades with a net deficit of 13,016,000 cubic yards, including the 4-foot soil cover. Areas above the final fill grades will be trimmed to final grade, and the trim material will be placed in the spots in deficit. Additional waste received since development of the map used to estimate existing fill elevations, contaminated soil excavated from the water feature, and imported soil will be used to bring the areas still in deficit up to grade for the base of the final cover. Once the waste fill has reached this grade, a network of perforated pipes will be embedded in shallow trenches in the top of the fill, and a geocomposite gas collection layer will be placed over the entire site. The pipe network will be connected to a passive venting system at the east and west ends of the site. We anticipate that once the final cover is in place, gas production will decrease and passive venting will be sufficient. However, provisions will be made for converting the passive vents to active gas collection if it proves to be necessary during post-closure monitoring. The final cover for the transfer station and recycling area on the west end of the site and for the parking lot to the north is a low permeability asphaltic cement concrete pavement system, which consists of a 3-inch thick, low asphaltic cement concrete layer, a layer of geogrid or geotextile reinforcement, followed by another 3-inch thick asphaltic cement concrete layer, and a 2-foot minimum layer of compacted soil. The low permeability asphaltic cement concrete mix will be used to limit infiltration. Plus, the reinforcement mitigates the potential for cracking due to waste settlement. The final cover configuration for the vegetated areas of the Back-Hotel landfill consists of a 2-foot minimum layer of cover soil material capable of sustaining vegetation, a 2-foot minimum layer of foundation soil material, and a GeoNet passive gas collection layer, and an associated gas vented pipe network. Excess water will run off the cover system into a drainage channel around the site perimeter. The drainage channel also runs along the boundary between the transfer station and recycling area and the main waste body. The water then drains from the perimeter channel into the water feature on the east side of the site.
So we had 3 goals for the site selection of the new landfill area. The first was to accommodate the Gambia's municipal solid waste disposal needs for the next 30 years. The second was to provide easy access via major transportation routes, and the third was to provide sufficient space for operations as well as future expansion. We scanned Google Earth aerial photos to find such a site. Here's a diagram of the proposed landfill layout. In the top right is a soil stockpile area, and the bottom right is a leachate aeration pond and flare incinerator or microturbine. Then we have an equipment yard, landfill office, as well as a parking area. Right after the entrance is a scale house, and then there's a recycling area, white goods storage, and a space for hazardous and excluded waste storage. We also included security fencing around the perimeter of the landfill, and of course in the center is the wasteful area. In order to calculate the required volume for the new landfill, we made a few assumptions. The first assumption was that we assumed the current population of 2.4 million people would grow to about 5 million people over the next 30 years. We also found that the amount of waste produced per person per day was about 0.5 kilograms, and we assumed that this would also double over the next 30 years. This information was used to calculate the required waste mass. Then the mass was converted to necessary landfill volume based upon the assumed in-place density of the waste, 65 pounds per cubic foot. To determine the soil requirements, we assumed a 4-to-1 waste to soil volume ratio, meaning for every 4 trucks of waste, we would need 1 truck of soil. Using this information, we found that the volume needed for the landfill was about 39 million cubic yards, and about 10 million cubic yards of soil would be needed for landfill operations. On the left is the simplified geometry for the landfill volume calculations, and on the right is the detailed geometry for the landfill design. We assumed a simplified geometry of a truncated pyramid with a square base of length L and 3-to-1 slopes, truncated at a height of 150 feet. Using this simplified geometry, we found that the length is 3,150 feet, provided a volume of 40.5 million cubic yards, which is a little bit more than the 39 million cubic yards needed, which accounts for potential inaccuracies associated with the simplified geometry. For instance, the simplified geometry ignores benches on the slopes. The area of landfill footprint is 1.1 square yards. So for 10 million yards of soil, we would need to excavate about 30 feet below grade. This can be seen in the detailed waste geometry diagram. On the left is a cross-section for the cover, and the right is the liner system. The groundwater protection system for the new landfill was developed in accordance with US EPA standards. It will include a composite liner system composed of a geomembrane underlain by a geosynthetic clay liner, a leachate collection and removal system, and surface water drainage controls that shed as much precipitation as possible off the waste without contacting the waste. We made provisions for the use of a geosynthetic clay liner and GeoNet rather than just clay and gravel in order to make it easier to construct with local resources. The liner system will be overlain by a protective layer at least 2 feet thick prior to general waste placement. All precipitation that contacts the waste will be treated as leachate. The surface water drainage controls will also be configured to prevent surface water from running onto the waste. The new landfill will also be constructed with appropriate environmental monitoring systems, such as groundwater quality and landfill gas monitoring and gas collection systems. The new landfill will be capped with a final cover as sections of the facility reach final grade. The final cover system will include a geomembrane overlain by at least 2 feet of vegetative soil cover.
We now estimate the cost of the closure of the landfill. The total estimated cost for the landfill closure was $5.8 million. In the local currency, this amount is equivalent to 301 million Gambian dalasi. The major costs involved in the closure of the landfill include the construction of the landfill cover and the earthwork. This slide shows the details of the cost estimate. We see that the major cost involved in the closure of the landfill is the construction of the landfill cover, about $4.6 million. The second major cost is in the earthwork, about $0.8 million. And there are a few minor costs associated with the construction of the transfer station, perimeter channel, vegetation on top of the landfill cover, and for the landfill gas control. In order to finance the construction of the landfill cover, we will seek funding from various international conservation and sustainable development organizations. Since we are planning to construct a nature reserve on top of the landfill, we believe that our funding request will be favorably viewed by these organizations. In addition, for post-closure care, some revenue can be generated from the transfer station and from recycling. In order to finance the construction of the new landfill, we will seek bids from an international consortium to finance, design, build, and operate the new landfill for a period of 30 years. Further, we could explore the possibility of generating additional revenue by accepting waste from the neighboring country of Senegal. For this purpose, we could consider designing a larger landfill if desired. That concludes our presentation. We would be happy to answer any questions. Thank you.
Thank you very much, the team, for the brilliant work they have just manifested. Going by figure 2, which is post-closure development plan, you made mention of, I think, stormwater basin / water feature, that you're going to construct some perimeter canals. I just wanted to find out, because that would direct all the stormwater into one area, that's the eastern part of it, where we experience flooding during the course of the last rainy season. That place is almost full to capacity. So I am just wondering whether you're going to build a big pond or what, because the water cannot be stagnant at that place, because it's the proximity to the community is very close. It can be a breeding space for mosquitoes.
We'd have someone who works at the park more or less full time, or just occasionally, and this person would be in charge of making sure that the pond was sanitary, as well as having some sort of general infrastructure to clean the water.
Yeah, and also the second point is looking at all the closure and the development of the new landfill requires some capacity buildings and trainings. I didn't see in the presentation where you captured training or capacity building, because even at the closure level, some of the monitoring of some installation pipes and others need some personnel that need to be trained on, so that they can also be able to monitor what is really going in terms of groundwater, in terms of leakage and all those stuff.
Yeah, so the way we have the closure plan graded is that it would grade down towards that slope with a channel that goes around the park to collect water there. In terms of groundwater leaching, ideally, because it's a natural cover, hopefully we wouldn't get too much groundwater leaching.
Okay, thank you very much.
I'll
Thank
chime
you.
in a little bit, and first want to thank you guys as well for such an awesome work with very unique idea and thoughtful process that went into it. My question is on the old dump site. In trying to close that, you've talked about the vertical slope, the vegetated slope, and you've also talked about the cover where you have some asphalt, basically designing roads. So when you look at those numbers, you would see you have a compacted fill of a foot and 3 inches and 3 inches. That's a foot and a half that goes on the road and the tar. But when you look at the vegetated slope, you have a foot and a foot. That's 2 feet. So there's a 6-inch gap there where the vegetation would be higher than the road that drives through those places. My question is, why did you guys design it that way, and how do you anticipate that to work better than the other way around?
I believe that it was a 2-foot compact soil cover underneath the 6 inches of asphalt. But the idea was that 2 feet meets U.S. government regulations, so that's what at least we have deemed works well. So yeah.
So in the numbers you have, just to make sure I get it right, are you saying that the asphalt is the road is going to be higher than the vegetation, or is the vegetation higher than the roads?
The asphalt would be a little bit higher, but to meet up to that 6 inches, you would just add a little bit more soil approaching that area on the vegetated section.
And other question was about one of your images, so the contour plot, where was that contour plot I assume was for elevation, where the northern shore was higher elevation than the southern shore. Is that correct?
The western side of the landfill would be higher in elevation. So
in the process of closing it and designing it, as we just talked about, are you planning on leveling everything to a net level before the close, or are you planning on going along that elevation and gap to be able to design it, in other words?
Yeah, the plan was to get it to that grade, was to grade the waste and then add 4 feet or 2 feet of compacted soil and then 2 feet of topsoil on top of that.
Yeah, the top of the cover would have around a 2% slope for drainage towards the east side.
Thank you, Mr. Bob.
Thank you.
I had a question that kind of builds on what Laman was saying. It appears, and maybe it's built into the cap closure cost, it appears that perhaps your cost estimates for closure of Bacate don't include a lot of costs for groundwater monitoring or groundwater mitigation. So kind of building on what Laman said, if I think there's reason to believe there's likely an amount of liquid in the landfill now that may be contributing to groundwater contamination already. How would you handle that? Or if during design or monitoring phases you do detect a hit in groundwater, how would you propose mitigating that?
Right. So the table that I showed did not include groundwater monitoring costs. We will need to have some groundwater wells along the perimeter and sample it and test it for various contaminants. I'm not sure what the stratigraphy of the subsurface looks like, but that we need to do some sort of groundwater modeling to understand the transport of contaminants.
All right, I can go next. So I want to thank the Sun Devil Waste Consulting team for a good presentation and all your efforts on the poster and the report. And I really appreciate in your presentation emphasizing the site grading aspect. That is a critical component to kind of figuring out, whatever the steps are going to be. We have to really kind of, emphasize doing a good job with the site grading for the future condition of the Bacote dump site. And in your situation, that's a closure. My question is related to the new landfill location. So on your poster, and then also shown in some of the imagery, you show a site and highlight a site that looks like it's in close proximity to the River Gambia. Could you kind of describe a little bit about, the true distance away from the River Gambia that you guys, how you picked that location?
Yeah, so that location was based on population density, as well as distance from the River Gambia. I have the project pulled up actually, so I can show its more precise location with a screen share, but it's near the town of Somita, I believe it's pronounced, near the border of Senegal. And it's a little bit close to the River Gambia, but I wouldn't say it's terribly close. It's in a location that has relatively high elevation, so water won't collect on it too much. And I intentionally chose this spot because it's kind of further away from those smaller rivers that appear to feed into the River Gambia. So yeah, it's just because it's on that southern shore, kind of in the middle of the country, it's definitely going to be closer to the main river. But again, it's further away from those smaller rivers.
And about how far away is it from the current Bacote site?
It's about 64 kilometers.
Okay. And then the last question I had was related to, one of the slides was talking about the population estimate that you guys were considering, and you guys had an estimate of 2.4 million. Is that more so a basis of, kind of the current population of the Gambia? So you're just going to serve greater than just this urban area and in a broader area of the Gambia?
Yeah, that's what we were thinking. For the population estimate, I just got a population of the general area of the Gambia, and we assumed that we would service kind of that whole area.
All right, thank you very much. That concludes our Q&A session.